Hello, and welcome to the Gestalt IT Rundown for Wednesday, June the 1st, 2022. And happy first day of National Pride Month to all those out there. My name is Tom Hollingsworth, and I'm back with more great news of the week. Joining me is Mr. Stephen Foskett. Stephen, welcome to the show, and congratulations on making it through basically the first half of 2022.
Man, May was May, man, wasn't it? But man, a lot of news came out last week.
Yeah, it did. There was a lot of news about chips and supercomputers and, a couple of security stories, but what can you do about that? We're going to jump right into it, though, because NVIDIA announced last week that there is a new supercomputer that's being built by Los Alamos National Laboratories, and it's going to be powered by their latest chips named after Admiral Grace Hopper. The new chips, which are dubbed Grace and Grace Hopper, are part of the NVIDIA HGX platform that's designed for high-performance applications, and they provide twice the memory bandwidth of traditional HPC chips. The computer at Los Alamos is going to be called Venado, and it's going to be capable of up to 10 exaflops of AI performance whenever it's finally completed, when all of the parts get installed. Stephen, other than the fact that they're named after one of the most dynamic personalities to ever grace a computer ever, what is so cool about these new chips in your eyes?
Yeah, this is a really interesting story because, as we're going to talk about in a couple of minutes, ISC is when we learn the latest cool supercomputer news. And one of the things that came out of ISC was that there's really a stagnation in ARM-based supercomputers. In fact, ARM was very poorly represented at ISC this year, with the big exception being this story, the LANL Vornado supercomputer. And this is an AI supercomputer. So you mentioned 10 exaflops. That's 10 exaflops of AI power, and that is provided by the Hopper GPUs predominantly. So just as a reminder, Grace was NVIDIA's ARM-based offload card. It's basically part of a disaggregated approach to computing. And the idea was that they would put ARM CPUs along with supporting chips and accelerators on the network and allow those to communicate with a CPU that's sort of coordinating things, with the idea that they would eventually use this to build out a supercomputer. This year, NVIDIA announced what they called Hopper, which was their new next generation GPU. And in a wonderful twist, announced a combination of Grace and Hopper called, yes, Grace Hopper. And so we love it because it's such a great reference to Admiral Grace Hopper, as you mentioned. One of the things that was spotted, though, when NVIDIA was making these announcements is what's being called a Grace 2X Hopper, or a Grace Hopper, which is what I like to call it, basically combining two Hoppers in one Grace, and in a supercomputer form factor. And I am suspicious that that's maybe what we're seeing here. In other words, the HGX platform combining the ARM Grace along with the Hopper GPU being deployed in a supercomputer for AI processing. And that's really, really interesting because, number one, as I said, this is a different direction from what we're seeing on the supercomputer lists. Most of the supercomputers are more CPU-based supercomputers instead of exascale AI computing like this one. And also because it does use ARM cores. But the ARM cores aren't really doing anything other than holding up the GPUs, and that's pretty much what we're seeing. But that being said, next year's ISC, or maybe the year after that, could look a little different because Atos, Dell, Gigabyte, HPE, Inspur, Lenovo, Supermicro, all of them are working on exascale supercomputers using the NVIDIA HGX platform and Grace Hopper. And so I think that it's very likely that we may see ARM starting to rise in the ranks again. And at the very least, I think it's likely that the next exascale AI-focused supercomputer is going to be built on Grace Hopper. Tom, Microsoft announced this week that their support diagnostic tool has just a little bit of a flaw. The hole was discovered on April 12th and has been actively exploited ever since. Microsoft announced a plug that will patch this hole, going back to on their previous statement that, it wasn't really an important exploit after all. The bug allows an attacker to send a specially crafted Word document that you would execute remote code and avoid detection via tools like Windows Defender. What kind of damage are we looking at here, Tom?
Depending on how much you believe about how actively this thing was exploited, quite a bit. Yeah, all the way back in April 12th, this thing was discovered. One of those funny things about research, hindsight being 2020, they have samples of these specially crafted Word documents that were uploaded to Virus Total like a couple of days after the discovery of this exploit. And so Microsoft just immediately within like a week came out and said, yeah, not a big deal. It's a diagnostic tool. What's the worst thing that can happen? and the F around and find out crowd said, let's find out. And so what they did is essentially they sent you a Word document that can have embedded HTML because it's Word. It's basically like if Emacs was even more bloated, and allows you to pull down remote files, including a specially crafted RAR file with base64 encoded sections that can then be reassembled into a program that allows you to be running it with basically dodging all of the protections on your system and exploiting it. So yeah, I'd say that's pretty bad. Bad enough that Microsoft had to have a small side dish of crow whenever they said, yeah, actually it is bad and you really need to patch it. Current solution set if you can't get the patch deployed, just prevent the Microsoft diagnostic tool from being able to pull things down from the internet. Because that's what you have to do. The whole only allows you to do like the remote code exploit, but the stuff actually has to be pulled down, has to be downloaded from the internet, fetched from a random web server somewhere. So diagnostic tools should not be talking to the internet. Fix that problem until you can get all your systems patched. And then the next time that Microsoft tells you something is not a big deal, don't believe them. Go fix it. Go do your own investigation. And just so you know, the second vulnerable Word document was uploaded to Virus Total like on Friday. That's what finally got Microsoft to figure out that this is a big problem. So if you see things in the wild that look a little bit freaky, you need to upload them to places like Virus Total, because if you don't, the companies are never going to know just how bad things really are. So it's up to us to kind of keep an eye on things. All right, Stephen. So we just talked about Grace Hopper and NVIDIA, and guess what? It's new CPU day again. Because Ampere announced that they have a new server CPU, the Ampere 1. Now, you may recall that Ampere runs on ARM, and they have been a very popular crowd so far because the Amazon Graviton systems are based on an Ampere CPU. Azure has a bunch of ARM-based instances, so they seem to be a hot commodity right now. The value of the Ampere 1 specifically comes from the fact that the CPU can pack an incredible number of cores into the die. The current version of the Ampere system, not the Ampere 1, but the one that's being shipped, has about 128 ARM cores per die. Now, why would that be important to a cloud provider? Well, right now, companies that are running on x86 hardware have to use hyperthreading to create a virtual number of cores for things that might need a core-specific instance running, like, I don't know, a mobile game. I hear those are kind of popular, I guess. Ampere 1 doesn't need any virtual tricks to do this. It just uses a core. It can dedicate one core per thread instead of using crazy software trickery. Now, that means that there's a lot of headroom in this chip, and that's something that's super valuable for people who are not necessarily as concerned about performance as much as they're allowing specific performance per core. Stephen, what are your thoughts on Ampere 1, and do you think that this is going to shift the way that people in the cloud look at doing workload division?
Yeah, this is an interesting situation because, as I mentioned previously, when I was talking about the NVIDIA Grace Hopper CPU or supercomputer, we see that there are very few ARM-based supercomputers in the list and talked about at ISC. And similarly, if you look at what AMD and Intel, especially Intel, are doing with their CPUs, it's all about the accelerators. In other words, Intel's claim to fame with the Xeon CPUs are that it has all these wonderful specialized instructions that accelerate specialized use cases that are widely found in enterprise technology. So AVX 512 and all those other SIMD instructions. Well, we haven't seen as many of those accelerators on the ARM side, with the big exception being Apple. Apple's M1 has a lot of really powerful accelerators in it, and that's one reason the M1 is so powerful. But Ampere previously had used basically stock off-the-shelf ARM Neoverse cores. And so their previous generation had 128 kind of vanilla, decent but vanilla cores. And those were great for certain applications. And as you mentioned, the applications that really can use a huge number of cores are things that are going to basically be running one workload per core pinned. And that is basically things like cloud gaming. And the Ampere solution has been a very popular in that particular situation. So, not to be overshadowed by the announcements coming out of AMD and Intel and NVIDIA and ISC, Ampere decided to give us a little bit of a preview of what they're producing next. And what they're producing next is pretty cool. So the Ampere 1 is going to move from those bone stock cores to a specialized Ampere design core. Now, we don't really know if that means that it's going to include much in the way of accelerators, and I'm actually going to take a guess and say that it probably isn't going to include much acceleration, except for the kind of acceleration that's needed by Ampere's core customers, which are people deploying things in the cloud. And that this thing is going to double down, triple down, quadruple down on that many, 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 many core in the cloud market, which Ampere has already been really cleaning up on. This is going to result in a really impressive many, many core solution for cloud service providers, and they're going to sell a ton of these things. But that being said, it's sort of a different path than what we're going to see Intel and NVIDIA and AMD embark on, because they're, as I said, they're all about high performance AI, accelerators, disaggregated computing, et cetera. Whereas Ampere is going to say, you know what? No, we're going to give you all the cores you can eat, and we're going to give it to you in a compact package that supports next generation things like PCIe 5 and the new generation of memory and all that kind of stuff, DDR5. And that seems to be really what Ampere is doing. And frankly, I love that. I love the fact that we're getting specialized solutions instead of just saying, you know what, we're just going to go after everything. No, we're going to give you a cloud compute CPU, and that's what Ampere 1 looks like it's going to be. As I said, though, this is still new. It's just an announcement. I can't wait to see what happens and what comes out of Ampere, and I look forward to that briefing. Tom, turning it to Let's Encrypt, the company announced a new initiative to free up some IPv4 addresses this week. Presenting at an Asian internet conference, the company announced plans to reclaim several sections of wasted space in the legacy IP address range. Specifically, they want to reclaim addresses starting with 240, 225 to 232, and 127. Now, listeners with eagle ears and maybe a CCE something background might recognize those addresses as being the Class D multicast and Class E experimental and loopback addresses. I'm not a networking expert like yourself, Tom, but how is this going to work?
The short answer is it's not. This is a proposal that's been floated around quite a bit. So in the grand old days of the internet, all the way back in the 70s, when Vint Cerf created all of the stuff that we know today as the internet, one of the things he decided was we're going to block the addresses. We're going to say we're going to create one class for big networks, one class for medium-sized networks, and one class for small. But based on the way we have these marked off, we have some other like administrative addresses. So like Class D was for sending one packet to a bunch of different places. That's multicast. Class E was marked as the experimental group, never to be used for anything ever. I have an analog for this for people at home. If I told you that my phone number was 5550141, what would you say? You'd probably say that I'm giving you a fake phone number, right? Because in the movies, 555 is a prefix that is not used in general terms. It is a fake number address. By the way, there is one 555 number in every area code. It is 555-1212, which is used for information. And that fact confuses a lot of people. Let me tell you why opening D and E and the loopback address is going to confuse people, because your operating system is hard-coded to reject those addresses as invalid. Go ahead, try it after the rundown's over. Go try to change the address of your workstation to 241.0.0.1. It will fail, because every operating system since the creation of time rejects that as an invalid address, because it has been an invalid address since the 70s. I get that Let's Encrypt is seeing all of this area of unused addresses and going, man, if we could just reclaim those, we could probably have more space available. This also reminds me of the people who don't want to move to 10-digit dialing because they don't like the idea of using more than 7 digits when they're dialing a phone number. We finally gotten over that, which, by the way, another fun little analog. The reason why we've set those addresses aside is because of a decision that we made back in the 70s. And if you don't think that technical debt can follow you around a lot, realize that it was 1995 when we were finally able to have area codes that did not have a 0 or a 1 in the middle of the number. And the reason why that decision was made was because all the way back in the early days of the telephone switchboard system, which was back in the 30s, all of the numbers started with a word. So like Klondike 5, you couldn't start any of those with a 0 or a 1. So the reason why area codes had zeros and ones in the middle was so that you could differentiate the area code from the prefix. We're dealing with that technical debt 90 years later because of a decision that was made back there. To the Let's Encrypt CEO that spoke at the Apricot conference, I believe it was called, let this one go, buddy. You're going to cause more damage than you're actually going to fix things. We just moved to IPv6 and the world is a better place. All right, Stephen. The US-based Oak Ridge National Laboratory has a new supercomputer. I know we've talked a lot about supercomputers throughout this whole thing, but this one's actually kind of awesome because it just set a speed record. So this thing is called Frontier. It is the first publicly benchmarked exascale computer. So it did a significant amount of floating point operations. Now, you may remember that we've talked about the previous record holder, which is the Japanese Fugaku, which does about half of what Frontier does right now. The interesting thing, though, we've covered Fugaku in the past. It was based on a custom set of silicon, which is what a lot of these modern supercomputers are doing, is they're building their own custom silicon to hit these numbers. Frontier is based on HPE's Cray EX platform, which is running a bunch of liquid-cooled third-gen AMD EPYC processors. So it's an interesting system setup that relies on effectively a version of commercial off-the-shelf CPUs. Stephen, I know that having like the big speedometer thing and claiming a record on the top 500 supercomputer list is kind of a badge of honor for like all of a month or two. But what are we really getting out of these speed races?
Well, it's interesting to kind of try to read the tea leaves here, because one thing that's I think I should mention is that we're actually not sure that Frontier is the fastest supercomputer on Earth. This is just the fastest one that's been benchmarked. It is very likely, in fact, some have said that it is patently obvious that there are faster supercomputers that are not being benchmarked because they're in secret spy agencies and defense agencies in, let's say, Beijing and Arlington, Virginia, just to guess. And that's probably true. I really doubt that the NSA is out there benchmarking their fastest supercomputer and publishing the results to the world. But the US national laboratories, in fact, the world national laboratories, have been happy to benchmark their systems and show just how far they've come on supercomputing. And as I discussed in my last two stories here on the rundown today, one of the things that's happening here is a rise in AMD-based x86 supercomputing. In fact, 51% of the new supercomputers announced are using AMD x86 processors. Another interesting fact is, as I mentioned just previously, the rise in accelerator-based computing. And in fact, the majority of new supercomputers are using not just CPUs, but CPUs plus accelerators. So for example, Frontier has 9,472 EPYC 7003 processors, plus 37,888 Instinct MI250X GPUs. That's one area that this performance is coming from, is from accelerators tied with really high performance many core CPUs. What we look at when we look at this, though, is try to find the trends. So Fugaku, well, for one thing, Fugaku is an amazing computer with a bunch of amazing people working on it. And in fact, they already have a next generation in the works that's going to be using more of these custom ARM chips that they were using previously. Frontier is just a different approach. What if we lash together a ton of, and these are not stock computers by any sense, but a ton of mostly stock CPUs and accelerators into a supercomputer. It's another great approach, and it's seeing a lot of wins for AMD. As I said, also you've got to look at these many CPU-based systems. And of course, you also have to try to read the tea leaves on what this means for the broader IT economy. So if AMD is really rising in the supercomputer space, it's very likely that they're also getting a lot of wins in other enterprise HPC, cloud, and data center applications, and that certainly seems to be the case. But at the same time, you also have to take some of this supercomputer stuff with a grain of salt, because it doesn't always reflect the needs of data center and cloud and service provider and et cetera, because many of those have different kinds of workloads, just like the workloads that are using the Ampere CPUs and cloud gaming. The enterprise data center may not need a EPYC and Instinct combination in the data center. In fact, they may be looking for something else. And the same thing with the AI supercomputers like we're seeing from NVIDIA. Those aren't applicable to enterprise workloads either, but they certainly are applicable to AI workloads. So what we have to do is we have to kind of figure out what this means for the AI industry in general. And I think one of the things it means is that, boy, AMD is doing great. They're supplying a lot of supercomputers with a lot of CPUs. They're supplying many supercomputers with accelerators. And they're also working with NVIDIA across the table to partner NVIDIA accelerators with AMD CPUs and indeed with Intel CPUs. And I think that that's a sign of what's going on in the economy as a whole. And frankly, it's really exciting to see supercomputer developments because they are exciting all speeds and feeds and all that sort of thing. But frankly, we have to do sort of step back and think about what does this mean for enterprise tech. And apart from some signposts, it doesn't really mean a lot. The only thing I can say is congratulations, AMD, and congratulations, Oak Ridge.
Well, Stephen, you mentioned the economy, and we had a couple stories we wanted to take a little bit of a closer look at. And one of these was kind of interesting to me because, let's be fair, you don't have to look very far to see that the current economic climate has a few little issues. It could be inflation, it could be geopolitical conflict, it could be the fact that the stock market is as shaky as an old red wagon going down a cobblestone road. So a lot of people are thinking there might be some trouble on the horizon. Well, you want another indicator? Sequoia, the largest venture capital firm, had a Zoom call last week, and they were telling customers and potential investors that the startups need to look at trimming their costs and reducing spending. They also warned that startups should be looking to raise cash now instead of hoping to get a big funding round later. Incubator Y Combinator sent a letter to their portfolio companies urging them to do something to get to a state they like to call default alive, which is a fancy term for being profitable with your current funding, or as I like to refer to it, running a successful business. Stephen, it sounds like the venture capital firms are sounding the alarm. Is there something here, or is it Chicken Little telling everybody that the sky's falling?
No, this ain't Chicken Little, baby. This is a warning, and it's a warning that the companies and especially the people out there should take seriously. If the people with the wallets are telling companies that they need to figure out how to become a successful, profitable company, that means these companies are going to be moving aggressively in a few different ways. Number one, we're going to see a lot more funding raised over the next few months so that companies can shore up their finances before any perceived downturn hits. Number two, and this is not such a great thing, is we're going to see layoffs. We're going to see a lot of companies looking to trim their margin or their budgets, and the easiest way to do that is with people. We're also going to see reduced spending on capital and operational expenses, reduced marketing spending, and so on. And I think that this is all a challenge for companies because, frankly, it's already been really upset by the pandemic and by the economic upheaval of 2020 and 2021. And now we're going to see more economic challenges in 2022 and 2023. I think there's going to be a lot of cuts. I think there's also going to be a lot of merger and acquisition activity. We talked previously about the VMware acquisition, which, by the way, is continuing to move along, with Broadcom looking to buy VMware. And one of the things that Broadcom is explicitly saying is that they're going to trim out a lot of employees. They're going to focus on profitability, and they're going to try to make that a profit-focused enterprise instead of a growth-focused enterprise. I don't think I'm misquoting Broadcom by saying that. I think a lot of companies are going to start looking at this, especially Silicon Valley companies, and that's going to pose many, many challenges for people. The third thing that I'm really concerned about here is that we often get a bit of a overreaction from entrepreneurs, from investors, and the fact that the investors are sounding the alarm, I think, is going to cause panic in the startup crowd. We may see fewer new startups launched in the next few years. Certainly, we'll see fewer of them funded. And frankly, we may see people throwing their money into more safe investments, bonds and things like that, instead of trying to invest in growing tech startups. And that's challenging for the entire enterprise tech industry. So this is really a concern for me. Tom, what are you hearing from companies out there in the space?
Well, it's kind of interesting because I'm one of those people, cynical, maybe putting it mildly. I believe that the best way to succeed in business is to have a business. That means that you concentrate on making money instead of growing. It means that you keep your operational and capital expenditures under control instead of just hoping to get your Series G round to pay off all of your debts. Now, here's where it gets interesting. The people who were providing all of that money, the venture capital firms, are faced with a problem because without getting too deep into Fed monetary policy, they have to raise interest rates to curb the current state of inflation. We know that. The question is, how much do they have to raise them to tap the brakes on the economy as opposed to slamming on the brakes and throwing everybody through the windshield? That is a job for people who have an economics degree. I do not. So what's going to happen is the first time interest rates go up by a significant amount, because they're going to be little increases, death by 1,000 cuts, people are going to stop lending money. You know why? Because they can't do it for free anymore. When interest rates are like 1%, it's effectively free money. I can lend it out and I can get it back and it'll be fine. The problem is the cascade effect that it has when that occurs, which is the stock market no longer has access to free money, which means they're going to constrict, which means all of these inflated stock prices are going to do this, which is what they've been doing. And you can't use that anymore as a leverage to either purchase companies, or you can't use it as basically an asset to borrow against. So now you've got a restricted funding pool, which means you're going to have to make your business work. I've heard rumblings of this for a long time, that certain venture capital firms were no longer going to stake a company with an angel round or a Series A for a proof of concept. You had to come to them with a fully working product to get your Series A, because they weren't going to take a flyer on this. I've always said that a lot of companies see an angel round or a Series A as a slot machine handle pull. I'm going to do 10 of these and one of them is going to pay off. And if that one pays off the way I wanted to, it'll fund the other 9 that didn't. I think venture capital firms are basically saying we're not doing that anymore, which means that, yes, we are going to see fewer startups getting started. That is part and parcel. But what we're going to see out of it, which I actually think is maybe going to be a better thing in the long run, is we're going to see healthier startups that get started, because they're not going to be like Uber. They're not going to burn billions of dollars to corner a market and then hope that they can raise prices later to make up the difference. I think you're going to see companies that if they're going to be disruptive, they're going to be disruptive in a way that makes money. Think companies like Nimble Storage, going all the way back. They were a business that made money that just happened to be a startup company. Because when we say startup, we have all these negative connotations of burning through cash, have a runway, need a series, whatever, to get to IPO or purchase. You're not going to see that. I think ultimately what you're going to get out of this is you're going to get a lot more positive companies in the industry that are going to be able to grow and weather any kind of a downturn that you get. And then those companies will go out and maybe their employees will leave to found startups when the cost of capital borrowing goes back to good ranges, if you want to call it that.
Yeah, and I do hope that this does not mean the end of venture capital and startups. But There's maybe a silver lining here in that if we start to hear Sandhill Road echoing, well, rational people the world over and saying maybe we should be focused on building companies that are, making money and producing products instead of companies that is just somebody else's R&D. Maybe that's a better approach and a better use of all the talent and resources in Silicon Valley. And I'm behind that.
Yeah. Well, Stephen, you mentioned ISC earlier in the show when we had some news coming out of it from Intel because they've released some new code names in the works for some of their high performance compute lines. They have a new AI GPU that's codenamed Rialto Bridge. They also talked about their next generation flexible architecture, which is going to be the one past 2023. They're going to call it Falcon Shores. Now, Falcon Shores lineup continues with this chiplet idea, which has the x86 CPU with the Xe cores kind of mated together to create a really configurable solution. Kind of as you mentioned, that sounds an awful lot like the Apple M1, where you have CPU and GPU kind of running together with this high performance memory and performance cores versus efficiency cores and things like that. Intel also finally showed off Ponte Vecchio, which is another Italian chip or Italian name chip. But Stephen, I'm not super familiar with Intel's roadmap here, and you are our expert on all of these things. So what exactly are we looking at here, other than the fact that we know that Rialto Bridge is kind of focused on the GPU AI workloads and that Falcon Shores is going to be kind of this chiplet design?
Yeah, well, I think that's the news, and that's what I really want to focus on here. As we've talked about, AMD is just doing a great job with their EPYC and Zen CPUs. The Zen core is great. The roadmap looks solid. And AMD has been putting together multi-core modules CPUs for a while now and really killing it. Intel, frankly, has been lagging a little bit behind. One of the reasons is because Intel had still been focused on a monolithic chip architecture, which frankly makes it difficult to successfully produce, it's all about manufacturing, to successfully produce many core CPUs because sometimes there's a flaw here or there. Chiplets give you a lot of options. Now, this is a very, very exciting thing, and I'm really going to focus here on Falcon Shores. But before I do need to mention, as you said, we heard a couple of names here, and Ponte Vecchio is a name that we've heard quite a lot. As you say, that's basically Intel's GPU for data center applications. The next generation is Rialto Bridge, and Rialto Bridge, frankly, looks great. It's going to be an incremental improvement over Ponte Vecchio. You can think of it as a tick in the whole TikTok Intel strategy, and good on you. But let me focus on Falcon Shores, and let me focus on a new term, XPU. What is an XPU? Well, the X is basically a variable. Think math. XPU is any kind of PU. So, you got your CPU, you got your GPU, you got your IPU, you got your DPU, et cetera, et cetera, et cetera. XPU is a new computing paradigm that essentially says, you know what, all of these are processing units. And it's about time that we just recognize that the data center is not CPUs and GPUs and DPUs and IPUs and whatever. The data center is XPUs, period. Full stop. We're done. And that, to me, is the exciting thing about this announcement. Falcon Shores is it's like a flashing neon sign of Intel's new strategy. And unlike a lot of the announcements from ISC, which have very little relevance in the data center and the cloud and even the client, this announcement has a huge amount of relevance. Intel, let's see what they're doing here. So Falcon Shores is specifically a next generation that would combine Xe graphics or GPU tiles and x86 CPU tiles on the same chip in basically any combination that a customer wants. So a Falcon Shores next-gen XPU could be all GPU, it could be all CPU, or it could be a mix of those. You mentioned Apple's M1. Well, M1 is really cool, but M1 has the GPU and the CPU and the neural processor and all that kind of stuff. They're all on the same die. And if you want more, as in like the M1 Ultra, basically you take two of those dies and marry them together. Falcon Shores has different processing units that you can mix and match married together in a similar way. It also has memory and bandwidth capabilities. You could think of it with high bandwidth memory, for example, on the same die, though I'm not sure if Intel has specifically said that. I think seems like something they would do. And you can have solutions that even have different kinds of processors. So again, this is not what Intel's talking about here at ISC, but look at this thing. If you can mix and match x86 and GPU, why can't you mix and match different kinds of x86 cores? Why can't you then take this same technology and make a mega core CPU using, for example, Intel's efficiency cores that we're already seeing on their client chips? You think 128 core Ampere CPU is cool? Falcon Shores technology could give us a, I don't know, 1024 core XPU. It could give us a 1024 core XPU plus, maybe some GPU for VDI acceleration. It could give us a big little architecture with efficiency and performance cores and some x86 or some GPU in there. It could give us all these things, and all of this is kind of built together just like the Apple M1 Ultra is. Now, this gives Intel essentially a wide open highway for the future roadmap. So where Intel had previously been really struggling with the constraints of manufacturing everything on one die, and that's all gone. And in fact, the Falcon Shores technology is, and I'm going to say this unreservedly, is a step beyond anything we've heard from AMD in terms of combining multiple chiplets. And for that, I say that this is the big takeaway. Intel has a roadmap that is better than the AMD roadmap for everything from client to server to cloud to HPC to AI. AMD is going to be playing catch up in the next generation, and that is not what we're used to in 2022 when 51% of supercomputers and everything, everything's going to EPYC. Well, that's going to change, and Falcon Shores tells us how they're going to do it.
Stephen, you are the expert, and I couldn't have said it better myself. I'm excited to see where this goes. And of course, as we look at things on the roadmap, there's always exciting stuff happening in the future. And that's why you want to tune in for the rundown. But speaking of exciting things that are coming up in the future, I wanted to let you know about a couple of things we have coming up. The first one is near and dear to my heart, and that's Cisco Live US, which will be happening in 2 weeks. We're going to be in sunny Las Vegas, California. No, not California. We're going to be in sunny Las Vegas, Nevada, talking about all cool things that Cisco is going to be releasing during the event. We also have a Tech Field Day event that's going to be happening. You're going to want to check out the website, techfieldday.com, to learn more about who's presenting and who's going to be there. Make sure you tune in June 14th and 15th for that. Stephen, what have you got coming up?
Well, on June 22nd through 24th, that's Wednesday through Friday, we've got Cloud Field Day 14. It's a very exciting event. Cloud Field Day is all about next generation, and it has some fun delegates. All of the delegates are listed on our website, and all of the companies will be soon listed. We're actually just waiting for a little bit of paperwork, but that is going to be another great Tech Field Day event. I'd also like to mention that we just published our entire schedule through the end of 2022. So if you go to techfieldday.com, you can see the full schedule.
Absolutely. And the full schedule for the rundown is the same as it's always been. It's going to be the 12:30 Eastern Time, Wednesday publication that you see and tune in for every week. You can also subscribe to us in your favorite podcast application of choice. We'd love to hear what you have to say about the rundown. We continue to bring you the greatest news stories of the week because we think that it's important that you learn about all the cool things that are going on and get our perspectives about them. We're going to go ahead and take it out for this week, though, and we will definitely see you coming up very soon, whether it's at Cisco Live, at Cloud Field Day, or any of the other things that we do. We can't wait to see you and talk to you about some of the cool stuff going on. So for Tom Hollingsworth, Stephen Foskett, and the rest of the Gestalt IT community, have an amazing week, and we will see you for the rundown next week.